my name is Farhanabila binti Rosman and my number matrix is A22A1113. First of all, data groups of connected occurrence, and data interpretation is the explanation of data's significance. A set of data is a collection of data that is usually shown as a table. Each column denotes a different variable and each row reflects a dataset question from a member. It displays the values as a random number for each variable, such as the height and weight of an object or value, and each value is referred to as a data sheet. The data in the dataset may have one or more members corresponding to the number of rows. In statistics, a dataset is an assortment of data that is used for data analysis and statistical inference. It is made up of a set of measurement or observational data taken from a certain population or sample. There are some essential concepts in statistics that are related to dataset. For example, a population is total collection of individual or objects that the dataset attempts to represent. For example, if you are researching the height of all adults in a country, the population will be the entire set of heights for all adults in that country. Next, in many circumstances, it is neither feasible nor practical to collect the data from the entire population. Instead, a subset of the population, known as a sample, is chosen to reflect the entire population. Variables, traits, or features of the individual or object in the dataset. They might be numerical or categorical, which is qualitative and quantitative. Age, income, gender, education level, and survey responses are all examples of variables in a dataset. Each observation in a dataset represents a distinct unit or individual within an estimated population or sample. It represents the variables, values, or observations for that specific unit. Statistic datasets are frequently organized in a graphical fashion, with each row representing an observation and each column representing a variable. The datasets are then analyzed using a variety of statistical approach to discover patterns, correlations, and insight. The dataset may also be used to build an algorithm for specific types of software for testing purposes. We use software such as SPSS to analyze the selected dataset. We are given a dataset of life insurance charges with 1339 observations for this assignment. We decided to choose 350 out of 1339 random cases life insurance based on the lowest matrix number of our group members. Our dataset is secondary data. Secondary data is information gathered by someone else for a reason other than the one for which is currently being used. It is information that has already been gathered by primary data collection methods, prior studies, or other sources. In other words, using existing data for other purposes. Secondary data, when compared to main data, may conserve time that would have otherwise been spent on data collection. The sole downside of this data is that it may go out of data if not updated. Moreover, our dataset can be viewed from the perspective of different fields, which are BMI and charges. For the field age, the number of classes is 7 and the class interval is 7. For the field charges, the number of classes is 7 and the class interval is 6000.5 respectively.
Okay. Hi, I'm Siti Umaira binti Nordin. My matrix number is A22A0306. Now I will present about sampling data and record categorical data. Sampling data is a process of choosing a group of members or things for a study in such a way that they each present a sample of the target population. Sample techniques, sample size, and response are three variables that affect how representative a sample is. Categorical data is a body of knowledge that is organized into categories. Categories, qualitativeness analysis, graphical analysis, interval scales, numerical value, and nature are some general properties of category data. Next, the number of individuals or observation included in a study is referred as the sample size. Usually, N is used to indicate this number. The size of sample affect to statistical properties such as the accuracy of our estimates and the study ability to draw conclusions. And now we use the smallest last two digits number of our group members, metric numbers, as our sample size of the observation, which is 0.6.
My name is Nur Aina Najwa binti Abdul Wahab and my number metric is A22A1212. Next, I'm going to talk about numerical descriptive measures. First, about measures of central tendency. A measure of central tendency is a single value that attempts to describe a set of data by identifying the central position within that set of data. The three commonly used measure of central tendency, which is mean, median, and mode. As you can see in this slide, this is one of the BMI table. For the mean is an essential concept in mathematics and statistics. For mean for BMI, we got 30.09. This is the formula that we use, and we use this formula also for charges. Next, median, which is median number in a set of value. For BMI, we got 35.13. The formula also used in to calculate charges. Last, about mode. Mode is the value that appears most frequently in a data set. The higher charges for life insurance in BMI is 5,879.84. Next, about measure of position. A measure of position is the method that position a particular data value has within a given data set can be identified. The most common measures of position is quartiles that are divided into four parts. First quartile for BMI we got 26, and third quartile for BMI we got 34.25. And then we use formula third quartiles minus first quartiles, and we got interquartiles. For BMI, interquartile is 8.25. We also use the same formula to calculate for charges. Lastly, about measure of variation. A measure of variation is a conclusion statistic that represents the amount of depression in a data set. Measures of variation can help convey meaningful information about sets of data. In this case, we're going to look into three measurables, which is range, variance, and standard deviation. For BMI, the range is 33.1, and variance we got 768.59, and lastly standard deviation we got 27.42. All the formula that we use for range, variance, and standard deviation we also use to calculate for charges. That's all for me. Thank you.
Assalamualaikum and hi, my name is Nurul Izzatul Izani binti Muqtadir. My number metric is A22A1237. Next, I would like to present a graphical representation. Graphical representation is the process of effectively visualizing and streamlining data sets using simple charts. Data is loaded into graphing software and various symbols such as lines in a line chart, bars in a bar chart, or slices in a pie chart. Then used to depict the data. Additionally, because there's two variable quantitative data, they can both be visualized using a scatter plot, histogram, frequency, polygon, or ogive. To depict the edge and charge in these sections, we shall use a histogram chart. Histogram BMI frequency graph. A histogram is a graphical presentation that shows cumulative frequency, a very upper class boundary. To draw a histogram to represent each quantitative variable data, several steps are required. The first step is to create a frequency distribution table. A schedule must be include cumulative frequency as vertical scales or y-axis and upper class boundary as horizontal scale or x-axis. After creating the frequency distributions table, the upper class boundary is required a plot on each class in the x-axis, the corresponding cumulative frequency, and each box must be plotted. It should be noted histograms with class intervals of the same size represent the frequency of each class interval with rectangles having the same width, and the height of each rectangle is proportional to the frequency. Below is a cumulative frequency table with upper bounds for each class and a cumulative frequency histogram graph. From the histogram, we can see that the graph is labeled as x-axis with upper boundaries. So the graph starts in the first class with upper boundaries at 19.5, where the frequency is 11, and ends with the last class with upper boundaries at 49.5, where the frequency is 3. Therefore, we can conclude that the highest life insurance BMI is between 25 to 29, because it is the highest frequency compared to other classes. For second graph is histogram charge frequency graph. From the histogram, we can see that the graph is labeled as the x-axis with a midpoint, so that the graph starts in the first class with the midpoint at 4137.01, where the frequency is 131, and ends with the last class with the midpoint at 52146.01, where the frequency is 1. Therefore, we can conclude that the highest life insurance charge is between 1137.0 to 7137.01, because it is the highest frequency compared to other classes.
Hi, my name is Nur Shazrina binti Issa.
and my metric number is A22A1250. Next, in this slide, I will talk about statistical analysis using SPSS. Statistical analysis is the process of collecting and analyzing data to identify patterns and trends and inform decision making. First part of the statistical analysis is numerical descriptive measure. In numerical descriptive measure, we use two ways to calculate the numerical descriptive measure that contains mean, median, mode, standard deviation, variance, range, minimum, and maximum, which is using SPS and manually. We also calculate manually for quartile 1 and quartile 3. The dataset consists of 350 valid observations for charges and BMI. As you can see, there is a little bit of difference between SPSS and manually. For example, mean of BMI. Using SPSS, mean for BMI is 30.6321. Meanwhile, using manually, mean for BMI is 30.09. Next, I will show you the graph by using the SPSS. This is BMI histogram graph by using SPSS. From the graph above, the x-axis is the midpoint and the y-axis is the frequency of the BMI. The last graph is charges histogram. From the graph above, the x-axis is the midpoint and the y-axis is the frequency. As you can see, the highest frequency in this graph is 50.
Hello and selamat sejahtera. My name is Hanisa binti Morosli. My metric number is A22A1238. Hypothesis testing is a type of statistical method that involves putting your assumptions about a population parameter under the microscope to see how they fare, and it also to determine the plausibility of the null hypothesis. A statistician performs an hypothesis test on a statistical sample in order to present evidence that it has some validity. So if you can see here, we have a t-test from step 1 until step 5, which is step 1, state null hypothesis and alternate hypothesis. Step 2, we have state the level of significance. Step 3, we have computer test statistic, which is we have two tables here. Table 1 is group statistic, table 2 is independent sample test. For the step 4, we have decision rule, and last but not least, we have step 5, which is making a decision and forming a conclusion.
Next is ANOVA. As you can see, this is the ANOVA table. The p-value from the ANOVA table is 0.001, which is less than 0.05. But one of the variables above can be used for moderate charges of the life insurance. Now, let's go through for the correlation analysis. Correlation is used to test relationship between quantitative variables and categorical variables. In statistics, the word correlation refers to the relationship between two variables. As you can see in this picture, there is a 4-step for the correlation analysis. The first step is hypothesis, which is in H0 there is no significant correlation between BMI and charges. Meanwhile, in H1 there is a correlation between BMI and charges. Step 2, significant level, which is 0.05. Step 3 is SPSS output. We are using Pearson correlation table for this correlation. Step 4 is decision rules, and last step is decision. As you can see in this correlation, there is a scatter plots metric for BMI and charges. Next, I will explain about confidence interval. Total for the equation is charges we got is 8454.537 plus 257.663, which is for age group, plus 400.705, which is for BMI. For every unit that increase in BMI group, the charges of life insurance will increase 400.705 and the age group remain unchanged. Same, for every unit increase in the age group, the charges of life insurance will increase 257.663 and the BMI group remain unchanged. The 95% confidence interval for the BMI group is 178.723.622.687, where the value of 0 falls within the interval. Therefore, the 95% confidence interval for the age group is 170.806.344.520, where it is same that the value of 0 did not fall within the interval.
So the conclusion is, to summarize, we can complete all of the statistical computation required for this report using the data we collected during our lecture. We utilized a sample dataset of 350 from 1239 that included two fields, which is we have BMI for variable X and charge for variable Y. We also utilized the independent sample t-test and an ANOVA table to assess hypothesis. And then we also used a scatter plot and a correlation table to do correlation analysis. And also, we developed a theoretical regression model that allows us to employ many factors at the same time to explain variance in a continuous dependent variable, resulting in multiple linear regression. This shows that the age group increases the charge of life insurance by 400.705, while the BMI group remains unchanged. Then, when the BMI group increases, the age group remains unchanged, while the charge of life insurance increased by 257.663. And last but not least, the age group is significant predictor of charge since the 95% confidence interval is 170.8 and 344.52 with 0 lying outside of this range. That's all from me. Thank you.